Anybody have anything that, if you missed it, you figured it out after you got done? Yeah?
I just have like logistics, like if we're a teeny bit late, will you like stop the quiz even though someone might be in the middle of it, or is it just, like is there a specific time that you'll stop it?
It's set up, everybody who's here should get 5 minutes. It goes on at actually 1:58, we've decided, right? And turns off, supposed to turn off right at 5 after. So if you're a little bit late and you can still get time to get it, not a problem. But if you're turning it on and you only have, everybody notice at the bottom there's a countdown? Keep an eye on that. If it's like you turn it on and it's saying, 1:48, that means you have 1:48 to finish that test because it's getting close to.
Like it's for certain going to stop at 5 after, no matter what time you started, or is it
Yes.
just like you're given 5 minutes?
If you started at 1:58, it'll turn off 3 minutes after.
Oh, okay.
But if you start right at 2 o'clock, it should give you the full 5 minutes.
I think I started a little late the other day,
So
and it stopped me right in the middle. And
yep, it'll do that. It'll do that.
Okay.
So hustle here and
Okay.
see what you can do to get. Yeah.
Can we go over prime power factorizations? That was one.
Specifically what?
Well, I just got that one wrong. Because one of them, I think the answer was it was 2 squared, and I put just 2 times 2. So does that have like a prime power factorization?
If I ask for prime factorization, 2 times 2 is just as good as 2 squared. If I ask for prime power factorization, then they should have the powers on them. Yeah.
Then if you ask for prime factorization and we do the prime power, is that okay, or do you want it more
Yeah,
simple?
that's okay too.
Okay.
Yeah. Yes.
I was just wondering if you could go over the twin primes on the homework, the sheet that you gave us yesterday, how to take on finish.
Okay. So what's a twin prime?
It says pairs of numbers like 3 and 5 that differ by 2.
Okay. That's the definition of them. So are there primes that they differ by 2? The number in between them will always be what?
2.
Huh? Even number.
Yeah, not.
It'll always be an even number, so it won't be prime. So we can never get 2 prime numbers next to each other except for where?
2 and 3.
2 and 3 are the only ones that you can get that are next to each other, because after that there are no evens that are primes, right? So they've defined a twin prime as one that has just one number in between it. So we want another example would be 11 and 13, because 12's between them.
So 5 and 7 would be twin primes.
Mhm.
6, 7.
Yep, that's all it is. And all I did that for is I wanted to show you kind of how they're scattered out. And the question I ask you about how many consecutive composites you can get together, just to give you an idea of, you can't get very big, long stretches before another prime pops up. And in this class, we're not going to prove that there are an infinite number of primes, but there are. Okay?
So this is more for my curiosity. When I watched the video they had us watch, how do they stop people, like people who know how to do that, like go into computers and find the big number, the little prime number and the big number? How do they stop people from doing that, stealing people's money? Do they have like a program that notifies them?
They have an RSA is a security. Trying to remember what it stands for. I think it's the people that R and S are 2 people that developed this, and that's the thing that allows you to put your put your credit card into the internet, and it gets encoded with this here, And the only way a person could decode it is check the divisibility of this huge number that has come up with by taking one huge prime times another huge prime. And in order to find that, even having computers that are way fast and networking computers together, at the speed that computers go, they still can't discover it. So it's a pretty safe.
So how do they come up with it to begin with?
The person who develops the code has chosen the key. This is called public key cryptography.
He's the only one that knows it.
Well, he's the only one that does, but he publishes the key that allows it to be translated. Therefore, people can encode their stuff. But when it gets back to the company, then they can use what, and nobody. It's almost uncrackable at this point. Now, as computation improves and computers speed up, we might need to move to something different. Yeah, that's an interesting. Public key cryptography is what keeps the internet commerce going. And it has to do with number theory and great big prime numbers. Yeah. Any more questions that came out of that sieve that we were asking? That we didn't have you upload it, but we said go through, and if you have questions about it, we could talk about it. Yes.
I have a question on the homework. On the key for 9B, was it wrong?
I don't know. It might be. What was the question and what did the key say?
It said, the question is how many factors does each of the following numbers have? And the problem is 4 to the second times 6 to the 6th times 22 to the 6th. And the key said it was 16 plus 1 plus 7, and 6 plus 1 plus 6 plus 1.
You gotta break it down.
Instead of doing 2 plus 1.
You gotta break it down further.
I threw a curve ball at you here. Who caught it? What is it that I wanted you to get out of this problem?
It's not simplified.
These numbers are not prime. This is not prime power factorization. That's not prime, and neither is that. 4 means 4 times 4, and 4 can be split up into 2 times. So that's really 2 to the 4th. And this right here is 6 times 6 times 6 times 6 times 6 times 6. But each 6 is a 2 and a 3, so it's really 2 to the 6th times 3 to the 6th. Well, I've already got 4 powers of 2. There's 6 more, so it's 2 to the 10th, really. Okay, and then 22 is 2 times 11. So that's 2 to the 6th times 11 to the 6th. So there's 6 more 2. So that's really 2 to the 16th. And I've got 3 to the 6th and 11 to the 6th. Now I've got prime power factorization. Now I raise this one, this one, this one, and I multiply and I get my answer. So the very first thing you need to do if you're doing a problem like this is, are the bases of the exponents prime? If they're not, you need to get them that way, or you can't even do the trick that we learned on Wednesday. Does that make sense? Okay. Good question, by the way. So do you think my key's right now?
Yeah.
Okay. Good. But I'll bet you there were... How many of you are glad she asked this question? Oh, see that? It was not a waste of class time. Good. All right. We've covered the Civ questions. We've covered the homework questions. Yep. The quiz, the beginning of class questions. Right? There was a problem about lockers. I'd like you to turn to your partner and talk about how you approached it, and if you solved it, what you ended up getting. Okay?